Alright, check 1, 2. Alright, check 1, 2. Quite a bit of lag. We don't seem to be in the lab. Notified about 2 minutes ago. Good, you got it right on time. Alright, check 1, 2. Quite a bit of lag. We don't seem to be in the lab. We're going to get some echo here. Oh well. Okay then, let's get this show on the road. Good morning, boys and girls. Time right now is 10:07 a.m. Saturday, January 9th, 2016. And I've finished nano coating all of my copper wire for the Magrav energy beads, as well as some additional copper wire. And what I have here to show you is the difference between a nano-coated copper wire and a not nano-coated copper wire. So let me just pick this one up, and I'll pick this one up as a prime example of the most nano-coated, and I'll take this one as an example of the least nano-coated wire. Alright. I'm going to be using this video clip in the final production video as evidence that these wires have been properly nano-coated and uniformly nano-coated. Incidentally, this right here is a section of wire that I brought up from the workshop down below. That is a section of wire that was part of the wires that I was using for the original Magrav energy beads, and I'm going to be doing a couple little tests on this one as well right now. So one thing I noticed is that my hypothesis is correct, that the nano coating is non-conductive. This is a piece of wire. This is the tightly wound copper wire that became very heavily blackened much more quickly than the rest of them, and the feel of this coating kind of feels like a plastic enamel coating, quite frankly. And if I take my digital multimeter, and right now I am on the 20 k ohm scale. Alright, I'm on the 20 k ohm scale, and I can take my probes and touch them on the wire. Oops, you don't see the meter, do you? Let me move this in closer so you can see it. There we go. So we're on the 20 k ohm scale, and I touch the wire, and I'm applying quite a bit of pressure here on the wire, and I'm getting no conductivity at all, at least on the 20 k ohm scale. So I'm going to go right up to the 2 mega ohm scale. Alright, and if I just hold it with my fingers, you can see that holding it with my fingers, you get some resistance. There's about 1 mega ohm right there, okay? And I'll touch the wire again with my probes, and I still have, oh, I must have broken through the coating. Or we're getting some sort of capacitive effect. No. Okay, so the coating is not very durable. You can easily push your way with the probes through the coating if you apply enough pressure. And this is probably what's happening to make the circuit when the wires are being twisted together. Okay, so this is a wire that was very heavily coated. Here is an example of a coiled piece of wire that is not very heavily coated, and I will touch this with my ohm meter. And with this one, I seem to be able to get a reading practically anywhere by just by touching very lightly. So I'm not going to use this one. But here is a nano-coated copper wire that is completely black. Alright. And it's quite a bit more difficult to get a reading. There are places, if I push hard enough, I get a reading. And that really is the nature of the beast. Okay, if I go to the 20 k ohm scale, however, yeah, so as you can see, no matter how dark the coil is, if you press hard enough on the coating, you will break through this coating. And this will be true of any method that you use for nano coating the copper wire. Now, keep in mind what the term nano really means. Alright? Nano means very, very nearly infinitely small, comparatively speaking to dimensions that people are used to thinking in. So nano is a very, very, very thin layer. And the fact that we even have discoloration on the metal indicates that we have a completely nano-coated layer. It will be interesting, I think, as an experiment to see if I can twist a couple of wires together without making a contact. And if I can, it will then be interesting to find out what the dielectric strength is of the insulating material, which is really copper oxide, for those of you who really want to know what this is. And having said that, here is my example of wire, again, that is the least coated. It's like a bronze color. And unless I really press into the wire, I do not have conductivity on this either. So really, this piece of wire also is suitable. And I think any of you who nano-coat your copper wires, if you check it with an ohm meter, not a volt meter, but an ohm meter, you will see that the copper will conduct if you press your probes into the surface layer of the copper. Alright, so these are ready to be assembled into the Magrav unit. Here is the non-nano-coated copper wire, and I'm just going to very lightly rest the probes on it, and immediately we show conductivity. Alright, to show you I'm just going to let the weight of the probes themselves, I'm going to hold the wires out here. Okay, so this is the weight of the probes themselves, and they're just breaking through the surface layer of this copper wire. And showing us conductivity. So these will be used for the Magrav energy beads. Here is the piece of wire that I had earlier, and I am kind of interested to see how easily I can get some conductivity out of this. So yes, I don't have to press very hard to get conductivity on the areas of the wire that do appear to be bare, and the areas of the wire that appear to be copper, appear to be more thoroughly nano-coated. I've got to give it some pressure before I get through that layer. So I do accept the observation that the first wires that I used to assemble the Magrav energy beads were inadequately nano-coated. I will not accept any argument that these wires are inadequately nano-coated. I will not accept any argument of that nature. So we're going to be reassembling this a little bit later this morning after I get some heat in the workshop. We will be repeating the experiment and recording the results. That's it for now from Zero's computer desk, and I'll see you in the lab a little bit later.